Today I'm going to be going over lesson 6.02, mole number relationships. How many atoms or molecules are in a given amount of substance? We measure quantities in convenient units like pair, six-pack, and dozen. Chemists use a similar concept called the mole. The mole is an important concept in stoichiometry. Here you will learn about the mole and how it can be used to convert from numbers of atoms or molecules to mass. Goals for this lesson. Identify the quantity of 1 mole as set when the mass of carbon-12 equals 12 grams. Define 1 mole as the amount of a substance with the same number of particles, either atoms or compounds, as 12 grams of carbon-12. State Avogadro's number. Apply mole concept to calculate the number of particles in a substance and the amount of a substance. So here's our map. We're going to talk about the mole. Moles can be expressed numerically as 6.022 times 10 to the 23rd, just like a dozen would be expressed as 12. A mole is also called Avogadro's number, and it allows conversion between the number of particles and mass. I already downloaded the study guide for myself, and I copied down the keywords and pronunciation. Again, Avogadro's number, which is a mole, is 6.022 times 10 to the 23rd. And a mole is that many of anything. So it's 6.022 times 10 to the 23rd of anything. So, example. Particles, atoms, Skittles. Okay, it doesn't matter. It's 6.022 times 10 to the 23rd of anything. And you abbreviate it as MOL. That's right. The E comes off. That's the whole difference. All right. How can you count molecules when they are too small to be seen? It says we often need to know the number of atoms or molecules in a given amount of a substance. Consider a typical 8-ounce glass of water. How many molecules of water are in that glass? Molecules are too small to count individually, so how do you answer this question? Consider how we handle expressing the numbers of things. When you buy eggs, do you buy individual eggs or a dozen? When you buy fruit juice, you might buy a 6-pack. Like when you buy those Capri Sun juice packs, they come in a 10-pack. For numbers, we often quantify them by using convenient units such as dozen or a 6-pack. Chemists do the same for atoms, but they use another grouping. A mole is a unit for measuring numbers of particles such as atoms or compounds. Atoms are very small, and billions of atoms are needed to create even a small object. Consider the number of grains of sand on one beach. It takes millions and millions of grains of sand to create one beach. Similarly, it takes billions and billions of atoms to create one object of everyday size. When counting atoms, we can't use the idea of a dozen or even a gross. A gross is a dozen dozens or 144. Keeping track of numbers of atoms requires a special unit. The mole is a basic unit of measurement in chemistry for keeping track of the number of atoms and molecules, or in the case of ionic compounds, formula units. 1 mole of any element, molecule, or formula unit contains exactly the same number of particles. Whereas a dozen is 12 of anything, a mole is 6.022 times 10 to the 23rd of anything. And where did such an unusual quantity come from? Well, let's look at our moles of sand first. So we have a molecule of silicon dioxide, which is what makes up sand. Right? Then we can see here we have molecules of silicon dioxide. And so we'll look down here. So originally we started with 1, and now it takes 2.3 times 10 to the 19th molecules of silicon dioxide to make 1 grain of sand. So this picture is a grain of sand, like you would pick up one little piece. That one little piece is made up of 2.30 times 10 to the 19th molecules of silicon dioxide. So as in you'd count 1, 2, 3. And you'd keep going until you got a number that big. And so let me just write that out real quick. 2.9, and let me double check. Sorry, 2.3. Okay, that's how many we're talking. Okay, so it's pretty crazy. So we got hundreds, thousands, millions, billions, quadzillions. 23 quadzillion molecules. So 23 quadzillion of these things to get 1 grain of sand. And then how many grains of sand do you need for a beach? Well, it says here that you would need 2.62. So 2.62 times 10 to the 4th. 2.62. They're saying, I guess it's a pretty small beach. That would be like my daughter's sandbox, I think. 26,000? Yeah, that's not a whole beach. That's like my daughter's sandbox. And when we have that many grains of sand, we have 1 mole of silicon dioxide. So not a beach, they're saying here. We're having a mole. And look at this number, 6.02 times 10 to the 23rd. So when we have 6.02 times 10 to the 23rd molecules of silicon dioxide, that's about 26,000 pieces of sand, and that's 1 mole. All right, now obviously you don't have to have these numbers memorized. The point of this is to really grasp how big a mole is, how many molecules, and when you have that many molecules, what it converts into. All right, so I'm going to delete these numbers because we don't need those on our notes. Okay, so I added this little phrase to our definition of a mole. So just like a dozen means 12, a mole means 6.022 times 10 to the 23rd of anything. So I started the notes by copying the first sentence here. The mole is a unit for measuring numbers of particles, such as atoms or compounds. And then again, how atoms are very small. So go ahead, hit pause, and update your own notes. Chemists defined a mole based on carbon 12, or in other words, 12C. Chemists needed to standardize a mole, and they had to set a standard that everyone could agree on. That's super important because when we think about medicine, we need everyone in the whole world to agree on certain quantities so that when they dispense medicine, everyone's on the same page. Chemists defined a mole as the amount of a substance that contains as many particles as there are atoms in exactly 12 grams of carbon 12. So they took 12 grams of carbon 12 and they said, okay, this amount is going to be called a mole. So that's how they came up with 6.022 times 10 to the 23rd. The particles being measured could be anything a chemist might be interested in: atoms, molecules, ions, and even electrons. So a mole measures a substance according to the number of its particles. No one is absolutely sure where the term mole came from. Some think that is from the Latin mollis, for little pile, while others think that it is a shortened version of molecule. If it does come from a little pile, that fits because 12 grams of carbon is a lump of coal, about the size of a standard deck of cards. Okay, so chemists decided how big a mole was based on carbon. Okay, so what I added to my notes, there's chemists decided how big a mole was by looking at 12 grams of carbon 12. Carbon 12 just means that it has 6 protons and 6 neutrons. Because remember, we can have isotopes, or they can be fat and have extra neutrons, or they can have less neutrons than the average. So that's why it's carbon 12. So 6 protons, 6 neutrons. This is a lump of coal about the size of a deck of cards and contains 6.022 times 10 to the 23rd carbon atoms. So that's how big a mole is. We have this huge number, and when you put all those atoms together, you basically get a deck of cards. So think about that. That's crazy. So again, there are 6.022 times 10 to the 23rd particles in a mole. Amedeo Avogadro, who lived from 1776 to 1856, was an Italian physicist who determined that the volume of a gas is related to the number of molecules in it. While his idea led to the development of the mole concept, Avogadro didn't actually determine how many particles a mole has. Instead, it was Austrian physicist Johann Joseph Loschmidt, who in 1865 determined that there are 6.022 times 10 to the 23rd items in a mole. Just like there are 12 items in a dozen, 144 items in a gross, and, everybody say it with me, 6.022 times 10 to the 23rd items in a mole. We call this Avogadro's number. In 12 grams of carbon-12, there are, by definition, 6.022 times 10 to the 23rd atoms. A mole of anything contains 6.022 times 10 to the 23rd items. A mole of hydrogen gas contains 6.022 times 10 to the 23rd hydrogen molecules. A mole of marbles contains 6.022 times 10 to the 23rd marbles. That's a lot of marbles. You have to know this number, okay? That's why they wrote it like 100 times, because you need to know it. All right, so question, what is a mole like compared to a dozen? It's like a mountain instead of a molehill. Ha ha ha. All right, not that funny. How big is 6.022 times 10 to the 23rd? As you can see from the exponent, Avogadro's number is very large, almost too large to imagine. Some comparisons might help you visualize it. If you wanted to produce a book with 1 mole of words, it would take 1 billion printers, each printing at a rate of 10,000 words per day, more than 1 billion years to make the book. If you distributed Avogadro's number of dollars to the entire human population, each person would get $1 trillion. A stack of Avogadro's number of pennies would stretch most of the way across the Milky Way galaxy. So even with those comparisons, Avogadro's number might still be too large to really comprehend. If you had Avogadro's number of unpopped popcorn kernels and spread them over the entire United States, the country would be under a layer of kernels about 15 kilometers or about 10 miles deep. 10 miles of popcorn kernels. Okay, so this number is crazy, crazy huge. And then, okay, so we talked about how huge these are. Now remember, how big did we say if I had a mole of carbon atoms? So these crazy big numbers, but if I had a mole of atoms, it's only the size of a deck of cards. So that really is just like, whoa, mind-blowing how small atoms are and how big this number is. Avogadro's number relates the number of moles to the number of particles. You can now begin to relate the number of particles in a substance to the number of moles by using Avogadro's number, often written as N sub A, because A for Avogadro, N for number. Here are some relationships. Number of mole. If I have 1 mole, I would have 6.022 times 10 to the 23rd particles. If I have 2 moles, well, you just double it, right? If I have 3 moles, you triple it. If I have 5 moles, you times your number, 6.022 times 10 to the 23rd, times 5, and you get the number 3.01 times 10 to the 24th. Or if I have X number of moles, if I want to know how many particles that is, I just times the number of particles times 6.022 times 10 to the 23rd. So I added to the notes, relate the number of particles in a substance to the number of moles by using Avogadro's number, often written as N sub A. If I have 5 moles and I want to know how many particles I have, since each mole is 6.02 times 10 to the 23rd, I take 5 times 6.022 times 10 to the 23rd equals 3.01 times 10 to the 24th. And that's going to be the end of part 1.